Aloha and welcome. In this lesson, we're going to be talking about packages. Not these kind of packages. We're talking about other packages. We're talking about Python packages here. And Python packages, although not as good as getting packages in the mail, they're pretty cool because with packages, you can load lots and lots of functionality with an import statement, and you're not going to have to go and, like we were doing before, individually download or import modules one by one. So the idea of a package is it's a directory that has a bunch of modules in it. And these modules are usually related in functionality, like you'll have a graphics package, you'll have audio packages, things like that. The thing that makes it a package is that you have in that directory what we call a dunder init file. So you've got the double underscore init underscore double underscore .py file. And in that, you'll have perhaps some imports of sub packages or modules. Sometimes it's just empty. It doesn't have to have anything in it at all. So you have that file in there, and that specifies that, hey, this directory is a package. And when you go to import that, you're going to be loading in all the modules from that. You can also call them out individually if you wanted to and load them individually. So to that end, let me show my screen in VS Code. So the structure for a package, you usually have your directory at the top level, package name. Then under there, you're going to have that dunder init file. So you're going to have that dunder init file, and then you're going to have directories for your sub packages, like sub package 1. And under that, you'll have another dunder init file with its own, sub package, information if you're going to import other sub packages and stuff. And then you have your method, or not your methods, you're going to have your modules here. And we could also at this level, have, since we're at the package level thing here, we'll, have like module, module c.py here, and you could access that. So when we go to import this, we just do an import of package name. It corresponds to the directory. But something to keep in mind here is, how is it going to find that package name? How's it going to find that directory? Well, it's going to go back to something we talked about in the module section, and it has to do with sys. So when we look at what's in sys path, it's going to have the directory here that we're currently working in. It's also going to have a lot of the Python, there was an environment variable for Python and some other things. It's going to be searching in there for the directory. So if you had your own packages within the directory you're working in, you could easily link them in there. Otherwise, it's going to be looking at those other locations that we mentioned in the previous lessons. So it's going to check your sys.path to find the name of that thing that you're trying to import. If it finds it, it will import the directory that has the dunder init in it, and you'll have access to all those packages. Now, how do you access different modules within that package? Well, it's the good old familiar dot notation. So if we were using the example above and we wanted to access, well, first of all, let's import package name, and that's not going to work. But we do something like if we wanted to access module A, we would access it using dot notation. We'd go like package name dot sub package 1 dot module A. And this is how we would do it. So this is the module. And then let's say we had a function within there called, I don't know, walk. So we just put walk, and we could access it this way. So this is how you're going to be accessing the different things. You use dot notation to drill down through your package name, the sub package names. If you're like going for module C here, you would just, you'd skip this and you would have module C, and then you could access whatever names you have in there, whether they're methods or whether they're variables that are in there. You could access them this way, but use the dot notation to do all this. So why do we use packages? Well, one reason is it lets us load in a lot of functionality without having to individually call in different modules. But it also helps us avoid what we call name collisions. And a name collision is something where you have something named let's say you had uh, print, let's call it print label. Let's say you had something named function named print label. Well, if you had that in the global scope, it would be hard to have a print label across different modules. Let's say that you had some modules that were for printing labels for packages and some that were for printing labels on letters. And if you had them both defined in the global scope, you would run into a problem that, the print label would be ambiguous there, and you'd be overriding one with the other, and it would really get out of hand. So the nice thing about having it in packages is now you can import the package and you can specify the namespace for it. And we call this the namespace, like package.name dot, and then the actual modules. By having it in its own namespace like that, you're not going to have collisions, and you can have things that have the same. You can have variables and method names that are shared, even though you would think that calling print label would have a problem. If you have them defined within the namespace, you just call the namespace dot whatever name you need, the variable or the method, and it will. You can do it across different modules. So that's the benefit to doing this. But that also raises another point, and that's that when you're hoisting things, remember we can do an import of package name or import of module name, things like that. We can also do that more specific surgical hoisting into the global context, where we do something from package name import such and such. And what happens is it'll take that up into the global context to make it easier to use, so we don't have to use dot notation to get to it. If we wanted to call the function walk or something like that, we wouldn't have to every single time call on package name dot module c dot walk. We could just say from package name dot module c import walk, and then we could just use walk all the time. That's convenient, but if you've got all these similarly named functions across different packages or modules, you want to be careful about hoisting up into the global level, because you may end up overriding things. So yeah, keep that in mind when you're doing it. But in general, packages are great. They allow you to load in lots of functionality just by specifying the directory of the package. And these package directories are unique in that they have the dunder init file that's necessary to specify that as a package. And you can also pull in sub packages through that. And the great thing about packages are, it allows you to pull in lots of different modules without having to import them specifically individually. And it also gives you the ability to have similarly named things in different modules. They just have a different namespace associated with them. So keep that in mind. If you have any questions about any of this stuff, feel free to reach out, send me an email, or set up a Zoom meeting, and I'd be happy to meet with you and talk this through. So have a great day, and I'll see you in the next lesson.